We're going to be looking at disruptive selection at this point. Again, we have our bell curve, our average individuals below and above average, and I have all these terms in quotation marks because, technically we're not always using numbers, so I'm using the terms below and above kind of loosely here. So in disruptive selection, what we need to know is that on both ends of the bell curve, both extreme phenotypes, they have an advantage at the same time. That means they have a higher level of fitness than organisms that are at the average. And if they can survive better, they can have more children, meaning this trait starts to become more and more common in the population, as does this one. And if this continues to go up and continues to go up, what happens to the average? Well, we have kind of a shift from the middle to both sides. What we see happen to the shape of this bell curve is something like this, where we have a bump going up on one end, a bump going up on the other, and then the percentage of individuals that are average starts to decrease. What we're essentially starting to see is the formation of two new averages. And in the event where this line, where we were average, if that should get to zero, if that were to go all the way down to zero, then we wouldn't even have one graph anymore. We would have two graphs. There's one. There's the second. They are not attached any longer. What we would have then is speciation, or the formation of two new species from one original population.